So today I will do about ASVAB Mechanical Comprehension. So I will divide different kind of topic because on the topic will be on the test. First, we learn about force, gravity, work, three types of Newton's laws. About energy, we will talk about potential energy and kinetic energy. About the power, we do about chemical, electric, nuclear, solar, horsepower. In here I put the star because the horsepower will be appear on the test many times. The horsepower is so important. The friction, compression, balance, the force, tension, mechanical advantage. About mechanical advantage is so important too. They will appear many times on the test. Then I will introduce about simple machines. In a simple machine, we have inclined length, level 1, 2, 3, pulleys, as weld, as and wheel, compound machine. In the compound machine, I will talk about the gear. Gear is so important on the test because they appear many times. Next, I talk about the heat, flexibility, fluid dynamics, pressure, tank and empty tank, Pascal law. In the test, the Pascal law is so important and the pressure is so important too. They appear many times for the liquid and the water, so that we need to concentrate something very important. That's about the force. The definition of the force is the strength or energies as an attribute of physical action or movement. It means that if we have the object in here and we don't have any force, if we apply the force in here, they will move for the force too. For example, if you push the box will move followed by the direction of the force. That's why we apply the force. It means we apply the movement for the object. So in here there are two types of the force. Let's say contact force and non-contact force. Contact force, it means we need to touch or we need to carry. That's why we have the contact force. So we have different kind of the contact force in here. First, we have the applied force. For example, we push the force in here. Spring force, this is about the string, they move up, then return back to normal. That's about the spring force. The thrust force is mean about the parachute. The parachute just like that. In here we have the one person on the parachute and we have the force in here. They put up because they need to have the contact with the air, so that they have the thrust force in here. So that's why the parachute. The next one is about frictional force. This means that we push the force on the ground and they can create the friction with the ground, so that they opposite side with the movement of the direction of the force, so that they have the opposite side of the force. That's about frictional force. This is about the movement. This is opposite side of the movement. Buoyant force. Buoyant force, it means we need to have the hot air in the balloon. We put the hot air in the balloon so that balloon can fly on the sky. So that's about buoyant force because we need to have the hot air to create a force for the balloon. That's why we call that is buoyant force. The next one is about normal force. Normal force is mean we put the object on the table. or on the ground, and the force is still stand over there. They don't move anything, but they still apply the gravity force, and in here the gravity is going down. However, we have the table. They keep the object don't sink down inside the ground, so we have the normal force. The top one is about normal force because we need to apply the table, so that's why we have contact force for this table. So this equal about the normal force. The next one is about non-contact force. We just study about magnetic force, electric force, and gravitational force. Why they call about non-contact force? Because they don't have touch anything. We don't touch anything, but they still have the force. For example, magnetic. We just put about the S and N near the metal, and they will stick together with the magnetic, but we don't touch anything, so they call about magnetic force. Similar with the electric force, just like we don't contact anything, but they still have the electric force. For example, that's about when you use the comb for the hair, they create the electric force. This electric force, just like the magnetic force, they will touch another object and they will brush the thing like the hair or maybe the skin. We don't touch, but they still have the force applied for the skin. That's why we have electric force. Then the last one is the gravitational force. For example, we have the apple, and we put on the ground. So on the tree we have the apple, and one day the apple is dropped, and it means that the apple live on the tree and they drop down on the ground. But the apple did not touch about the earth, so that's why we call about gravitational force, because they don't touch on the ground, but they still move down on the ground. That's why we call gravitational force is a non-contact force. One, gravity. This is so important because on the ASVAB Mechanical Comprehension, they will mention about most of them are gravity. So the definition of the gravity is the force that attracts a body toward the center of the earth or toward any other physical body having mass. This means that we have the earth in here and we have the object. If we have the object will go to the center of the earth because they apply the gravity force. So that when we have the object, they will turn to the center of the earth, and that's why we have the gravity force. The formula of the gravity force is about F equal to M multiplied with 3. 3 is about 9.8 meter over second power 2, or about square second, because that's about the gravity, and this it can be about acceleration of gravity. That's why we need to remember the definition of gravity and the formula of the gravity. I will ask, what is the mass of object if the gravitational force is 980 Newton and 3 is about 9.8 meter per square second, and we have the formula of the force is about F equal to M multiplied with 3, and in here we want to find the mass in here. So that we have m equal to F divided by 3. F we have 980 Newton divide 9.8. So that we have about 100 Newton or 100 kilograms. So the answer for this question is about a question on the real ASVAB. What is the vector quantity? So if we want to know about the vector quantity, we need to have two things. First, let's see about the direction. The second one is about magnitude, just like how large direction is about where they can go. So that we need to have two options in here, or we have two requirements to get about vector quantity. That's about direction and magnitude should have go together. And in here we have this one. We have the mass. They have the magnitude, but they don't have the direction. Similar, they have the magnitude, but they don't have the direction. Area similar, they have the magnitude, but they don't have direction. But we have A because in the gravity, let's see about the force. Force, we can see that we have A equal to A G. We know that the force, they have the vector, and the gravity, they have the vector. So that they have the direction because they can go anywhere. The magnitude, this is how large of the force. So that we need to have the direction and the magnitude together. Now I will talk about work. The definition of work is force acting on an object resulting in a displacement. This means that if we apply the force, the object will move to a new location. For example, we have the one object on the table and you move the object on a new location. This different location in here they call about displacement because you move the object to the from old location to new location. They call the distance in here is displacement. The formula of the work is force we use about the Newton and displacement we use about meters. We multiply together, we have about joules, and that's why we have the formula in here. What is the work if we move the box in 100 newtons and 5 meters in new location? We have the formula of the work is about force multiply with about D. D is about displacement. So we have the force in here is about 100 Newton. We multiply with the 5 meters. So that we got about 500 joule. So we do about J. And the answer for this question is about C. It's about the Newton's law of motion. There are 3 definitions in here. You must to understand the definition. You don't need to memorize the concept. You just understand what is the first law, second law, and the third law. So I will explain for you about the first law. An object either remains at rest or continues to move at a constant velocity unless acting upon by a force. So on the first law, we know that we have the object on the ground. If the object moves with the velocity of the vector on the top, they need to apply the force constantly. If they apply the force constantly, they will move the second way, that's about remain unchanged. If they want to remain unchanged, the force on here, they need to refer back to the gravity. That's why the object will be stand on the ground, or the object can move if we have applied the force constantly, so that the object will move with that velocity with the same force. The next one, let's see about second law. The vector sum of the force F on an object is equal to the mass m of that object multiplied by the acceleration a of the object. So we have the formula in here. I just write here. Force equal to m multiplied with a. I will illustrate the object. For example, we have m in here, and we apply the force. If we apply the force, we need to have the object to move, and we have this is a. So that we apply the force in here, so the object will move. And I have the relationship between F and A. If the acceleration go up, but the mass they don't change anything, the force will go up. And if the force going down, the acceleration will be reduced too. If m go up but I don't change anything, they will agree about the force. And another location for the mass, we have A is equal to F divided by M. Because we just divide both sides with the M, so that we have A equal to F divided by M. If F increase, A increase. But if M increase, force don't change anything, the acceleration will reduce. So that they have the relationship between F, M, and A. Because this is on the test, they will ask about relationship between the force, the mass, and the acceleration. The third law: when one body exerts a force on a second body, simultaneously exert a force equal in the magnitude and opposite in direction on the first body. For example, we have two persons, and we have two persons. Two persons, they are on the skateboard. So we have two persons, they were close together, and they are on the skateboarding. If one person, number one, apply the force number two, so that the number two will go far in here. However, the person number one, they will revert back, because when we apply the force to one in one person, you will get the opposite side of the force. That's why we go back in the backward. The person will go to the upward. So that if we apply one force for one person, you will go back to. I use on the real ASVAB. Which of the following statements in second law of Newton? We have A, B, C, D, and we need to analyze in each answer key so we can find the answer. The acceleration will change the force. We have F and because the acceleration will change the force, it means that if the acceleration go up, force go up. If acceleration going down, force going down. So this is about the second law of the Newton. That's it. But I want to analyze all the answer key. The object keeps moving with providing the force. So we have the force on the round. We have the object on the round and we apply the force on the object so that the object will move in the constant velocity. So this is for the first law of Newton. Two persons push each other. We have two persons. They push together on the opposite side. That's about the third law of the Newton. The object doesn't move or sink on the round. It means that the object in here, they on the round. But we have the gravity on below in here. But we have the force of the object. They keep the object, they don't to sink on the ground. So let's see about the first law of Newton. So the answer for this question is about A. If one person push another person, he or she will A. Move on the same direction, B. Move in the opposite side of the force, C. Unchain, D. Move on the right or left. We know that if one person push another person, let's see about the third law of Newton, and we know that if they push another person, they will receive another force in the opposite side. So the answer for this question is about B. We have the real ask question about the second law of Newton's. A worker moves the post by hand with the weight is 50 kilograms. 50 kilograms. After 5 seconds, the velocity has increased from 0 to 20 meters per second. What is the force on the object? So we know that we have F equal to M multiplied with A. A is about acceleration, but the question that just provide the time and the velocity, and we know that the acceleration, we have the formula is about velocity divided by time. So that if we want to find acceleration, we need to find velocity after and velocity before, the time after minus time before. So this is about the formula of acceleration. We have velocity at the after is about 20, and velocity at the beginning that's about 0. After 5 seconds, that's about 5. We minus 0 because at the beginning we don't have the time counting. So that we have 20 divided by 5 is about 4 meters per square second. So this is about the acceleration we need to find. After we find about acceleration, we apply the formula. M is about 50, and we have acceleration is about 4. So the force in here is about 200 Newton. So the answer for this question is about A. About energy. On the ASVAB, we will care about kinetic energy and potential energy. About kinetic energy, the definition is about the energy of mass in motion. In about, we have the formula Ke equal to 1/2 multiplied with m, and the velocity power 2. Let's see about the formula of the kinetic energy. About potential energy, the energy that is stored in the object due to its position related to some zero position. For example, we have the ball on the round in here. Let's say about the distance between the ball and the round. We have 5 meters, and we can thought that the position of the ball between the position of the round, there is about potential energy. The formula of potential energy is about PE is equal to mass multiplied with gravity and multiply with the height. In here we have 5 meters, the ball is about 10 kilograms, and we have the gravity about 9.8, so that the potential energy in here is about 10 multiplied with 5 multiplied with 9.8, and we got about 150. That's about 490. Yeah, 490. And this is about the formula. We need to apply kinetic and potential energy. In here we know that the sum of the power is about kinetic energy and the potential energy. This means that at the beginning the total power of the kinetic energy and potential energy didn't change. If they go to the new location or the new force, the new one in here, they will be the same, because the energy just transform from kinetic to the potential, or the potential energy transform back to the kinetic energy. But the total value, if they sum together, they are the same, because the total energy in here, they did not change. We have the next question on the real ASVAB. What is the relationship among mass, velocity, and the kinetic energy? We have A, B, C, D. In here, we need to know that kinetic energy is about 1/2 multiplied with m and a square 2 with the velocity. So in here we can see that we don't see anything related, because we don't know to swap the number. So if we swap the number 2 in here, we about 2 kinetic energy equal to m multiplied with the square velocity. So we have that the answer is about A, because they make the tricky question. They just move the number 2 on the kinetic energy, and they thought that we choose C is the correct, but you know that they have the square on the mass, but that is not correct. So answer A is the correct answer. What is the kinetic energy if m equal to 20 kilograms and the velocity is about 10 meters per second? So we just apply the formula. So we have the formula in here. We have 1/2. We multiply with 20 kilograms and we multiply with 10 power 2. So we have 1/2 multiplied with 20 is about 10, and we have 10 power 2. 10 power 2 is about 100. So that we have 10 multiplied with 100 is about 1002. So the answer for this question is about B. To apply another real ASVAB. What's a potential energy if m equal to 20 kilograms and velocity about 10 meters per second? Gravity is about 9.8 meters per square second and the height is about 10 meters. So to apply potential energy, we have PE equal to mgh. So that's about potential energy. We have 20 kilograms in here. Multiply with the gravity is about 9.8. Then we multiply with the 10. So we have the number and we just calculate together. We have 9.8 multiplied with the 10 is about 98. And in here we have 98 multiplied with 20 is about 1962. So the answer for this question is about B. What is the total energy if we have the data similar for this? So to calculate the total energy, we have kinetic plus potential energy. In the kinetic, we just calculate is about 1000. Potential energy is about 1960. So the total two number together is about 2962. So the answer for this question is about A. On the real ASVAB, what is the potential energy? And we know that potential energy, we have the formula. Mass multiply with the gravity multiply with the height. In here, we need to find which one they related to three variables. So that's about potential energy. First, distance and Newton. We know that we have the distance, but the Newton is about the force. In here, we have the Newton. We don't have the Newton in here. So this is about wrong because they don't relate it. Upward of the gravity, it means the refer on the gravity. It means this one they relate to gravity going down. So this is not related. Gravity's relationship to the mass. It means that we have G and we have M in here. So this one is a correct one. Velocity and relationship to the mass. We know that in this formula we don't have the V. So this one related to the kinetic energy. So the answer for this question is about C. What is the potential energy of an object if the weight is 4 pounds and the height is 50 feet? So we have A, B, C, D. In here, we need to convert 1 pound is about 0.45 kilograms and 1 foot is about 0.304 meter, because the potential energy and the kinetic energy they will use about kilograms meter per second and about meters. So we need to convert the pound and the feet into the kilogram and the meters. So in the potential energy, we have the formula M multiplied with 3 multiplied with H, and we have M is about 4 pound. We multiply with 0.45. Then we multiply with the gravity, that's about 3.8. 1 foot is about 0.304 meters. So we have 50, we multiply with 0.304. After we multiply all the number together, we got about 268 joules. So the answer for this question is about B. How about the energy and the power? In the energy, on the ASVAB, you need to concentrate about chemical energy, electric energy, nuclear energy, and solar energy. About chemical energy, it means that in the battery, they have the chemical reaction to create the energy. That's why we call them about chemical energy. Electric energy is about the flow of the electrons or sample. Because that's about the circuit, the flow of the electron, they go in on the circuit. That's why we have the electron go through on the circuit and the line will be on. That's why we call about electric energy. Nuclear energy is about the use about the platinum, uranium to create about the nuclear energy. So we have the nuclear of atom. Solar energy is about the energy from the sun. So we have the solar energy. That's they use the light and the heat. And the good example that's about solar panel. Because in the solar panel, the sunlight hit the solar panel and they create about the solar energy. The next one, that's about the power. That's the amount of force done during the period. So it means that if we apply the force, you create the work, and the work divided by time, they create about the power. So we have the formula is work divided by T, and in the work we just learn about that. That's about the force multiplied with the displacement divided by T. So we have the formula F multiplied with D divided by T. Another thing we need to concentrate as the unit. The unit of the power is about joules divided by second, and we have another unit that's about watt. This is so important for the test, and this is on the ASVAB Mechanical Comprehension. Ask what type of power for lithium battery? We know that in the lithium battery, they have the chemical inside. So that's the reaction in the chemical, they create about the energy. So that's the answer for this question is about A. What is the power if we move 5 kg object in 10 seconds? The new location is 5 meters than the original place with 20 newtons. So we have A, B, C, D. So we apply the formula of power is about W is about the work divided by T is about time. We have that W will become F multiplied with D divided by T. So we have the force is about 20 newton. We multiply with the 5 meters in here, and we have 10 seconds. So we just apply the formula, and we got about 100 divided by 10 equal to the 10 watt. So the answer for the question is about B. Our horsepower is about a unit of power equal to 550 foot-pounds per second or 745.7 watts. So on the ASVAB, you should remember two numbers, 550 foot-pounds and 745.7 watts. True number is on the test. They will ask what is the horsepower, what is the units of the horsepower, the actual units of foot. That's foot pounds per second and watts. So we need to remember two units and a two number because this is so important for the ASVAB. Last, horsepower is, so they will provide A, B, C, D. So we know that the horsepower is about 745.7 watt, or approximately about 746 watt. So the answer for the question is about C.